myself Dr. M. Laxmidevi, Associate Professor in the Department of CACDS at Institute of Aeronautical Engineering. In this video lecture, we learn about recursion in C and what are the different types of recursions in C. So, recursion, first we'll see the definition of recursion and then we'll go on discussing what are the different types of recursion along with some programs. So, a function which calls itself is called as recursive function and the process is called as recursion. So, recursive function, it is also a function, we can say that recursive function is a function which calls itself and this process is called as recursion. So, for example, consider this example, we can understand the recursive function with this example. So, here we have int main function is there. Inside the main function, you can see there we are again calling the main function. So, this is how we call a function. So, in the previous video lectures, you can go through the previous video lectures regarding to user-defined functions. So, there we have discussed in detail about the different concepts of functions. So, this is how we call a function. So, name of the function and then followed by semicolon. So, when we call this function, again control is transferred here, again the main function is repeated here. Execution of the main function will be repeated. So, thus this main function goes on calling the main function again and again. So, what this function does is, or this program what it is written for is, it is written for printing the statement recursion. So, it will go on printing the statement recursion until the program runs out of memory here. So, here main function is called again from inside the main function. So, this function will go on printing recursion until the program runs out of memory. So, this is how, this is a recursive, main is a recursive function used here and this process is called as recursion. So, example, there are other problems which we can solve with the help of this recursive functions. So, first one is factorial of a given number. So, we will discuss in detail about factorial, how to find the factorial of a given number with the help of recursive functions. So, there are other problems also which can be solved by using recursion. So, that is finding HCF of two positive integers. So, HCF is nothing but finding out highest common factor of two positive integers. Suppose we have 4 and 8. So, HCF of 4 and 8 is finding out the common factors for each one. So, 1, 2 and 4. Common factors for this are 1, 2, 4 and 8. So, highest common factor is 4 here. So, in this way, we can write a program for this by using recursive function. Next, we have Tower of Hanoi. So, this problem also can be stated in terms of recursive function. So, what is this problem of Tower of Hanoi is? So, there are 3 towers A, B and C here. So, we have 3 towers A, B and C and on this tower A, we have number of discs placed. So, these discs are placed in decreasing order from bottom to top. So, their sizes are decreasing from bottom to top. So, suppose n number of discs can be placed here. Suppose there are 3 discs. Now, let us see how we can solve this problem by using recursion or by using. So, what we have to do is, what is the problem statement here is, we have to move all the discs from here, from the tower A to tower C and there are certain conditions. So, in the same way as they are placed here, so we have to move from source to destination. Destination tower is C here. So, as they are placed on tower A. So, final output of this should be, so all the 3 discs must be placed in the same order. So, this is the output. So, if this is the input, this should be the output. So, we can make use of, there are certain conditions or constraints to be followed for solving this problem. So, we can make use of this intermediate tower, that is tower B, in order to move, and only one disc can be moved at a time, and another condition or another constraint is, so we cannot place a larger disc on a smaller size disc. So, that is the constraints. So, we will solve it in problem solving for recursive functions when we are doing the problems on recursive functions. So, there we will see in detail about how to write a program using recursive function for solving the problem of Tower of Hanoi. So, next one is Fibonacci number sequence. So, Fibonacci number sequences, suppose we have 2 numbers. So, the next one will be addition of these 2. So, next one will be addition of these 2. So, 1 plus 1, 2. Next integer or next number in sequence will be 3. 1 plus 2 will be 3. The next 2 plus 3 will be 5. So in this way, so this is the Fibonacci number sequence. So this problem also can be solved by using recursive functions. Now let us see how to write a recursive function and what are the constraints to be followed here and what. So for a function to be written in recursive form, so two conditions must be satisfied, or two conditions are required to be satisfied. So first condition is it should be possible to express the problem in recursive form. So that is what in recursive form means. So let us see it with the help of one example. Second condition is the problem statement must include a stopping condition. So this is also called as base condition. Stopping condition or base condition. These are the two conditions to be satisfied for any problem or for any problem to be written in recursive form. So it should be first one. Let us consider the program or problem of factorial of a given number. So how to find the factorial of a given number is, so factorial of a number n is, so we can write it as, so factorial of a given number n is equal to n into n minus 1 factorial. So this is how we can write, and for this the base function is, so suppose we write a function factorial. So factorial of n, so n value is given here. So this can be written as, so this can be again be expressed in terms of function. So n into factorial of n minus 1. So again it is calling the same function. So that is what stated here. It should be possible to express the problem in recursive form. And next condition is, this is condition 1 and this is the second condition. The problem statement must include a stopping condition or base condition. So here stopping condition is, so suppose we have a number 4 is given. So 4 factorial can be written as 4 into 3 factorial. This again can be divided into 3 into 2 factorial. So this can be written as 2 into 1 factorial. So this can be written as 1 into 0 factorial. So when we have 0 here, so factorial of 0 is equal to 1. So we can specify the base condition or it will go on repeating. So at this base condition, so this is the stopping condition what we are writing here. We can write factorial of 0 is equal to 1. Now let us see with the help of program. So let us write a program for this. So in order to find the factorial of a given number by using recursive function. So here we can see that this is the header file, main function. Program execution starts from main function. So this is the function definition. So here in the main function we have declared a variable x, integer variable. So by using scanf function, so we are reading the value of x. So suppose x is equal to 4. So here when x is equal to 4, in the printf statement what we are doing is we are calling the function. So this is the function call or calling function you can say. So this is the calling function, factorial of x. So whenever the program sees this statement, so control is transferred here. So this is the function definition. So function definition includes return type, then name of the function, and then the inputs or the parameters you can say. Now this is the base condition we have written. So this specifies the base condition or stopping condition. Base condition, and this one is the recursive form. Now see here, so if n is equal to 0, so if the number is equal to 0, then we have to return 1, else what the program is written as n into factorial of fact of n minus 1. So again this will call the same function. So whenever this line is executed, so again this is a function call to the same function. Again the control is transferred here, but now the value of n is decremented by 1. So this is how the problem of to find the factorial of a given number is written in terms of recursion. So let us evaluate the function. So this is the problem statement. So this problem, factorial of a given number, can be written as, so it can be written in terms of the function fact of n. So n is fact of n is equal to n into fact of n minus 1. So again this will call, so till for the values n greater than 0. If n is equal to 0, so there we specify the base condition. fact of 0 is equal to 1. So if we run this program, we'll get the output as factorial of 4 is equal to 4 is 24. So we know that factorial of 4 is 4 into 3 into 2 into 1. So this is equal to 24. So let us see how the recursive function is executed in the. So when a recursive program is executed, the recursive function calls, they are not executed immediately. So what they are done is, so they are kept aside on a stack until the stopping condition is encountered. The function calls are then executed in reverse order. Now let us see what is the meaning of these statements. So here we refer to the concept of stack. So stack comes into picture here, and then so let us see how this problem is evaluated. So this is, you can see here. Now first, let us, in the int main function, what we are doing here is, suppose we want to find the factorial of a given number. So 4. So 4 is the number given. We want to find out the factorial of 4. So factorial of 4 is equal to, so we are calling the function fact4 in the main function. So after that, so it will go to the control is transferred to the function definition. So there it will check the condition. If 4 is equal to 0, so it will return 1. So this condition is false. So when this condition is false, then this statement is executed. So here return what it is, again calling the function factorial of 3. So again it is calling the same function. Then again it will check the condition. 3 is equal to 0. So this statement is false. So this condition is false. So it will go to the else part and it will execute this line. So here again it will call the function fact. So fact of 2 this time. So n minus 1 is, so initially 4. So in the next call it will be 3. In the next call it is 2. And then again it will check the condition. Again the control is transferred to the function definition. If 2 is equal to 0, this is false. So again it will call the function. Now with 2 minus 1 is equal to 1. So 2 into fact of 1. So again it will call the function. So it will check this condition. 1 is equal to 0. So this is false. So then it will return. It will go to this line. It will execute this statement. So again it is calling this function fact of 0. Then it will check the condition. So here in the function definition it will check the condition. So if 0 is equal to 0, this condition is true. So when this condition is true, it will return 1. So again, so this is how recursive, this is how the function is calling recursively. Now let us see how it is, how the program is executed in the reverse order. Now as we have seen here, so it is, so this line is executing return 1. So the next one will be, so this returns 1. So here fact of 1 is equal to 1. The value of this is equal to 1. So this we are getting from fact of 0 is equal to 1. So this we are getting from here. So 1 into 1 is equal to, so this value is returned to this function. So here 2 into 1, 2 into 1 is returned here. So here 3 into factorial of 2. So factorial of 2 is, we got it as 2. Now 3 into 2, so that is returned to this function. So here, so that is what it, here it is returned. So 2 into 3 is 6. So factorial of 3 is 6. Next again 4 into 6 is evaluated to 24. So in this way we get the output as 24. Next, so let us see how the function calls are processed. So first the function calls are processed here. So in the increasing order, as you can see here, first the function calls are processed and then after the values are returned in the reverse order. So when we call the function, factorial of 4 is called. So then 4 into factorial of 3. So this function is called. Then after that 3 into factorial of 2 is called. Then factorial of 1 is called. Then after that factorial of 0 is called. So when this is called, so it will return a value 1. So this 1 value is returned here. This 1 value is returned here. So this value, then after that the return value for this is, so this will return. So see the order, you can see. Now it is going in the reverse order. So it is returning now 2 into factorial of 1. So fact of 1 we got it as 1. So this will return. Now this return value will be 3 into fact of 2. So fact of 2 is equal to 2. So 3 into 2, 6. Now here, so this will return a value 4 into factorial of 3. So factorial of 3 is 6. So 4 into 6 is equal to 24. So this is what we get in the main function. Now let us see it with the help of one more concept, that is activation record. So in the previous video lecture we have discussed that, so whenever there is a concept of functions, then activation record is important. So we need to talk about activation record, and first let us see what is stack here. So whenever there is a function called in the main function, the correspondingly activation record is maintained in the stack. So what is stack here? So stack is nothing but, so it is a portion of memory segment, or it is a part of memory segment. So from where data is stored. So, or you can say it is a memory segment. So here data is retrieved in last in first out way. So that means the last element which is inserted, so that will be the first to be popped out. So there are two operations supported on stack, push and pop operations. So push is nothing but to place the element onto the stack, and pop is nothing but to retrieve the element from the stack or delete the element from the stack. So that is next. Consider this program, so recursion, in order to find out the factorial of a given number. First, whenever the control is transferred in the int main function, we are calling the function factorial of 3. So suppose we give 3 as the number. Suppose n is equal to 3. So 3 is given as input, or x you can say. So we are giving x as the input, x is equal to 3 here. So we are calling the function factorial of 3. So in the stack, so this is the portion of a stack you can assume. So first some part of this is allocated. First, whenever main function is called, activation record for this is maintained, and then the corresponding variables are also maintained. For here x is equal to 3 here. Then after that, so in the main function we are calling f of 3. So f of 3 is, so the corresponding variable is 3. So n is equal to 3 here. So that value is maintained. Then again in this function f of 2 is called here. So f of 2 is, activation record for f of 2 is created. Then after that activation record for f of 1 is created. Then after that activation record for f of 0 is created. So when it comes to f of 0, so we have seen that, so we have written the base case. So f of 0 is equal to 1. So this is the base case which we have written. So from there onwards, the values will be returned to the, so from here the control is again transferred to where it has been, from where it has been transferred. So f of 0, it will return 1. So this function, it will return 1. So this return value is returned to the function f of 1. So here n is equal to 1. So as you can see here, so as the number of activation records, so this is f of 3, this is the activation record for f of 3, this is the activation record for f of 2, and this is the activation record for f of 1. So it goes on, the stack memory goes on increasing. So as the function calls are increasing. So here this is the activation record for f of 0. Now the values are returned in reverse order. So each time, so f of 0 will return a value 1. So this value is returned here. So now this part of the stack memory is popped out from the stack. So this is popped out from the stack. This is no longer available. This value is no longer available now. Now corresponding to f of 1. So in f of 1, what we have, n is equal to 1 here. Now what it is returning, n into factorial of 0. So factorial of 0, we got it as 1. So 1 into 1 is 1. So that is returned now. Now this value is, or this part of the stack is, so this elements are popped out from the stack, or activation record for f of 1 is popped out from the stack. Next after that, f of 2. So here in f of 2, n is equal to, local variable n is equal to 2 here. So when n is equal to 2, so it is 2 into factorial of 2 minus 1. So factorial of 1, we got it as 1. 2 into 1 is equal to 2. So now this value is returned to this activation record is deleted from the stack. Now the only activation record which is left is f of 3. So this 2 value is returned here. So 3 into return value here is 3 into factorial of 2. So that is 6. So after that, when f of 3 is also evaluated, control is transferred to the, this activation record is also popped out from the stack, and it returns a value 6 to the main function, and we get the output as 6. So factorial of 3. So this is how we can understand how the function calls are, how the activation records are maintained in the stack, and how the function calls are evaluated in reverse order, or how the values are returned in reverse order. So 3 into 2 into 1, 3 2s are 6. So this is the factorial of 3. So in the main function we pass 3 as the number, so correspondingly output we will get it as 6 for the given program. Now this is about, so in this way we can understand recursive functions. So thus we have seen that first the function calls are processed, and then after that the actual values are returned in the reverse order. Then we'll talk about the different types of recursions which are available. So there are mainly we can classify the recursion into 2 types. So direct and indirect recursion. The other one is tail and non-tail recursion. So there are other types of recursion also, like nested recursion and then tree recursion. So there, all those we'll discuss in detail now. So first one is direct recursion. So direct recursion is a function which calls itself directly. So that is called as direct recursion. The function is directly recursive if it contains an explicit call to itself. So for example, suppose for example in the main function, so we have written, we are calling the function A. So we have defined the function somewhere, and then there we are calling the function. Again we are calling the function A here. So this function is calling itself. So this type of function call is called as recursive function, or direct recursion you can say. Our function is directly recursive if it contains an explicit call to itself. So this function is calling itself. So therefore it is called as direct recursion. So for example, this is a definition, function definition which we have written. So if we have name of the function is fun, and number of parameters are 1, type of the parameter is integer. So this is the base condition which is written, and this is the function call. So again it is calling the same function. Whenever the control is transferred here, whenever this line is executed, control is again transferred here. All these statements will be executed. So this will go on repeating till this base condition is reached. So this is a function call, direct call to the function itself. So this type of function is called as direct recursion. This type of recursion is called as direct recursion. The recursive call will occur for positive values of x. So that is what we have mentioned the base case here. Now next one is indirect recursion. A function is indirectly recursive if it contains a call to another function which ultimately calls itself. So for example, we'll consider the same. In the main function, suppose we are calling the function A. We have written a definition, and here in this we are calling the function B. So again in the function B we are calling the function A. So you can see here A is calling B and B is again calling A. So that means indirectly it is calling itself. So a function is indirectly recursive if it contains a call to another function which ultimately calls itself. So A is calling B here, B is again calling A. So this type of function, this type of recursion is called as indirect recursion. So this program you can consider. So here name of the function is fun. So this function is calling. So if this condition is not satisfied, it will go to the else part. It will call the function 10. So name of the function is 10 here. So this is the function definition. So here in the function, so here again we are calling the function fun. So control is transferred here. So directly or indirectly it is calling itself. First, whenever this line is executed, control is transferred here. So after that, so at this point, control is again transferred here. So this type of recursion is called as indirect recursion. Next type of recursion we have tail and non-tail recursion. So tail recursion is a recursive function is said to be tail recursive if there are no pending operations to be performed on return value from a recursive call. So tail recursive functions are said to return the value of the last recursive call as the value of the function. The information which must be stored during computation is independent of the number of recursive calls. So the information to be stored, that is independent of number of recursive calls. Now let us understand it with the help of this simple syntax. Suppose we have tail recursion. So here this is an example of tail recursion. So name of the function is fun here. So this is a condition which we have written. So if n is greater than 0, then these statements will be executed, whatever statements we have written here. Then after that in the function, so we are again calling the function fun n minus 1. So decrementing the value of 1 and then value of n by 1, and again we are calling this function. So as you can see here, so this whenever this call is executed, it is not, that means here it is not storing any information. So here information to be stored during computation is independent of number of recursive calls. So this is the last statement, that is the recursive call. So after this, when the function call is executed, so when the return values are executed in the reverse order, so nothing is returned to the previous call. So this type of recursion is called as tail recursion. So consider the example of tail recursion. So this is a simple program to understand. Next is non-tail recursion. So non-tail means, so there are pending actions to be performed on return value, on return from each recursive call. So information about each pending operation must be stored. So the amount of information is dependent on the number of calls. Let us see the example for this non-tail recursion. So here we have a function, int main function is there. So here we have declared a variable x is equal to 3. So for the main function, when activation record is maintained and x is equal to 3 here. So x, here there is a function call. So f of 3 is, control is transferred to the function definition. So f of 3 will be evaluated. Activation record for f of 3 will be created. It will check the condition n is equal to 1, return 1, else return f of n minus 1 plus 1. So you can see here, so there is a function call. Along with that, so when the calls are returned, during return, so this also has to be processed. So after the function call, we have to add 1 to the function called. So f of fun of n minus 1, so n minus 1, now it is equal to 3. 2, so f of 2 activation record is created. So n is equal to 2 now, here n is equal to 3. Then after that f of 1 is created. Activation record for f of 1 is created. 2 minus 1 is 1, so 1 is created. So when 1 is equal to 1, so it becomes true. So when 1 is equal to 1, so it becomes true. So therefore it will return 1. So here we have a return value. So it will return 1 from where it has been executed. So it will return to the previous statement. So f of 1, now this, so it will run to the, it will return 1 to the previous function. So 1 is returned here. So previous value is 2, 2 plus 1, previous value is 2 here. When, so for f of 2, so f of 2 means f of, when f of 2, for f of 2 here, so this will be f of 2 minus 1 plus 1. So that is f of 1 plus 1. So f of 1 we got it as 1. So 1 plus 1 is equal to 2. So return value of this is equal to 2 now. Next, it will return to the previous function. Now f of 3 will be evaluated. F of 2 activation record is popped out. It will return a value 2 to the previous function. Previous activation record, f of 3 is equal to, so we can write f of 2, 3 minus 1, 2 plus 1. So f of 2 we got it as 2. So 2 plus 1 is equal to 3. So in this way, so it will return a value 3. So output, so when there is a printf statement, again the control is transferred here. Printf statement, when it is executed, you will get the output as 3. So in this way, we can understand non-tail recursion. So non-tail recursion, you can say that, so there are pending actions to be performed on return from each recursive call. Whereas in this case, so there are no pending actions to be executed from each recursive call. Next, what is the difference between iteration and recursion? So let us see the difference between iteration and recursion. So recursion is a technique of defining anything in terms of itself. So whereas iteration is a process of executing a statements or set of statements repeatedly until some specific condition is satisfied. So you can go through the video lectures where we have discussed about iteration. So iteration can be the iteration or looping structures we have seen. Looping in where there we have discussed about in detail about while loop, for loop and do while loop. So iteration can be performed by using all the loops. So there must be an exclusive if statement inside the recursive function specifying the stopping condition. So base condition is required for, so in order to write a problem in terms of recursive function. Next, iteration involves 4 steps. So initialization, condition, execution and then updation. So this we have seen. Next, not all problems they have recursive solution. Any recursive problem can be solved iteratively also. So the same programs which we have considered like factorial of a given number, so that you can do it by using iteratively also, by using different types of loops also. So recursion is generally a worst option to go for simple program or problems not recursive in nature. So next, iterative computer part of a problem is more efficient in terms of memory utilization and execution speed. So suppose if you have if your program want to be efficient in terms of memory utilization, then you can go for iteration. But memory utilization is not a problem, then you can go for recursion, because as we have seen that each time a function calls, so correspondingly activation record is maintained in the stack, and the stack memory goes on increasing. The memory occupied in the stack goes on increasing for each recursive call. So suppose we want to evaluate f of 4. So f of 4, f of 3, f of 2, then after that f of 1. So in this way the stack memory number of activation records will go on increasing. So if you don't want your program to be use memory efficiently, then you can go for recursion. If there is a constraint on memory usage, then you can go for iteration. Next is disadvantages of recursion. So there are some disadvantages. It requires stack implementation. So as for each recursive call, memory in the stack is allocated for in terms of activation record. So it makes inefficient utilization of memory. So as every time a new recursive call is made, a new set of local variables is allocated to the function. Moreover, so because of this, there is a slowdown in execution speed. So as the function call require jumps and saving the current state of program onto the stack before jump. So these are some of the disadvantages of recursion. So thus in this video lecture we have discussed about what is recursion, what is a recursive function along with programs, and also we have seen the different types of recursion, direct, indirect recursion, then tail and non-tail recursion. So in the next video lecture, we will discuss some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.